Hi, this is Cycle 2, Week 4, Science. This week we are doing 2 experiments. They're pretty quick, so I have additional experiments to lengthen the time. So the first one's is number 12, Speedy in the Van Cleves, and you need 1 washer and 1 yard of string. And I have additionally to grab 3 mason jar lids. Science tutors, maybe you guys can just grab the 3 for your class. That would be great. So the purpose is to determine the effect of the distance on the orbiting speed of the planets. So our research is what are the planets, and what do we still need to find out that how gravity affects the rotating planets, and what do you think will happen when we spin the washer from different lengths of this long string? This sounds like a very dangerous experiment with the washer, so I think this is just going to be a tutor only part, and then after we do this, I'm going to show you how to use the mason jar and to have the kids allow them to do it. So I'm just going to back up. So you're going to show the kids at the different lengths of string how fast this washer is going, so just like that, and then you would back it up and go like that. So you want the string taut is what it's called, and what you're trying to learn is that the shorter the string is, the faster the washer has to go. The washers just seem dangerous when you get a bunch of kids going, so I think we'll have additional string and a mason jar lid that kids can then play with it. And the string is not going to be as taut because it's not as heavy, but it's also a lot safer. So maybe do 3, switch, and let more kids try, or however you want to work that in your class. Or if you don't even want to do it at all, that's fine too. So you're just trying to show kids that when the string is shorter, the washer goes around more times. I have a video of an ice skater with her arms tight to her body and how fast she goes, and then when she puts her arms out, how she slows down. And there's another video about like a lot of spinning, and there's a little bit of explaining with it. So that's also a good one. Those are in your lesson plans. And the last kind of fun thing is, I think there might be some in the nursery, but there's those sit and spin toys, so kids can sit on them and they get really tired and they go faster, and then when they open up, then they slow down. So those are 2 additional activities. This is the idea of how long it takes to orbit the sun from Nicole, that you can show at that point and just kind of talk about that. So that's the first one. The second one is on the move, and this one is also a little bit shorter, but I think the second activity will be fun. So it says a pie tin. We're just going to use a Gladware just for keeping a marble and a piece of sandpaper cut to a circle. So now we're talking about why planets orbit the sun and how they keep orbiting and they don't stop. So research, what have we learned? We haven't learned, what's cycle 1, cycle 2, Newton's first law, but some of the older kids might know it from last time, and that's what this is demonstrating. So hypothesis, what do you think will happen when we roll this ball, this marble, around the Gladware with nothing in it? And what do you think will happen when we roll it around with the sandpaper in it? Okay, I'll be honest, you can't really tell the difference. So you're rolling it, and then you stop and you see how much longer it rolls. So you kind of get it going, and then you put the sandpaper in, and you roll it, and it stopped a little bit sooner. It's a very small difference. If I have time, I'm going to bring in some felt just to kind of test maybe different surfaces underneath this, or you can use paper. Anything that's going to cause friction is your point. The point is that in outer space, there is no gravity, or there's nothing to stop the planets from orbiting, and that's why they orbit the sun. When there is an outside force that acts upon it, then it would stop, but there's not an outside force. So here is my, okay, so here's your like on the move solar system, and here's an example of the movement, okay? I think this is gonna show it better, and I think it's gonna be more fun for the kids. I'm unfortunately not gonna bring this in for you, but I do think it's worth it for you to bring it. Because I just can't bring all that stuff the morning of. So you can still use your pie tin. You need just a small piece of cardboard. You need a matchbox car, and then you need different surfaces. Sorry, I need this. You need different surfaces to go underneath this piece. So things like a blanket or a jacket or a piece of paper. And what you're gonna do is you're just gonna test the cars, and you're gonna let them go. That fell off. You're gonna test the cars, and you're gonna see, do this on the floor. You're gonna see how far it goes, and you're gonna mark that with a piece of masking tape. And maybe your older kids or your helper or you can write on it, you know, just the ground. And then the next one, so then you're gonna put paper or whatever underneath, and then you're gonna test that, and you're gonna see how far it goes. And then you're gonna test a towel. That's not gonna go as far. Then you're gonna test a sheet. That's gonna go further, but not as far. And so that'll give the idea that this experiment was trying to give, but didn't show it as well. So our conclusion is just that the, well, you can read it, but inertia is the resistance. There is no inertia in outer space, and that's why the planets can continually, the gravity can go towards the sun, and it can pull in. And the distance from the sun is not, sorry, factors. I don't know. That's it. Good luck.